So again, we're splitting it into two parts, y-intercept form and general form. Now, I'm doing a lot of teaching. Like we're going through a lot of stuff and we're going through it fairly quickly because in an ideal world, this would be a recap of stuff we have done before. And for some people it is, some people it isn't. So that's why I'm sort of treading through it slowly, hopefully, but we're doing lots of things, aren't we? So leading into the weekend, hopefully we can set you up with your homework. So firstly, we've got the equation of a line, y equals mx plus c, y-intercept form. Okay. The other formula I've got here is the formula for slope. Okay, so we calculated that yesterday. We're going to combine them. Here we have two coordinates in space. We have x is 2, y is 1, and we have x is minus 2, y is minus 7. We want to determine the equation of the line that passes through both of these things. So, for the equation of a line, we need two things. We need the slope and the y-intercept. So the first thing we're going to do is calculate the slope. Okay? Through here, we label our scripts, x1, y1, x2, y2, and we're ready to straight away calculate the slope. Alright, put it in the formula. y2, take y1. Minus 7, take 1, divided by x2, take x1. Okay, we'll simplify it. We're going to have minus 8 divided by minus 4, which will simplify it to positive 2. The negatives cancel at the top and the bottom, and 8 divided by 4 is 2. So therefore, our line has a slope of 2. The slope between these 2 points is 2. So if the equation of a line is y equals mx plus c, then our line here is going to be y equals 2x plus c. We don't know what this c is. We don't know the y-intercept yet. We're going to figure it out. We do know, however, that it passes through both of these coordinates, which means both of these coordinates satisfy the equation of the line. So we can put any of these coordinates in to determine the value of c. Either of them's fine. Which one's going to be easier? This one. There's no negatives involved. So we're going to substitute this coordinate into this equation here. I'm going to put the y value where y is, so I'm going to put 1 there. I'm going to put the x value where x is. So I have 2 times 2 plus c. And we're doing this to determine what is the value of c that makes this statement true. Now, 1 equals 4 plus c. Now, most of these linear equations you can solve just by intuition, just by looking at it. But we did revise some of those processes yesterday at algebra. You can do anything you want as long as you do it to both sides. Here, we want to get c by itself. We want to know what is the y-intercept. So we're going to take 4 from both sides of the equation. So here, minus 4 and positive 4, that cancels. And we're just left with the c. That's what we're trying to isolate. And over here, we've got positive 1 and minus 4. When you combine them, 1 take 4, minus 3. So the value of c is minus 3. We've got everything for the equation of the line. We just need to restate it. Y equals 2x, take away 3. All right. Slope is 2, y-intercept minus 3. Here's the equation of the line that passes through these 2 points. So really quick recap. We're trying to find the equation of the line. We need the slope. We went ahead and we found the slope. And then we put the slope in. This is what it is, y equals 2x plus c. But then we said, all right, now we need to determine the value of c such that this coordinate lies on it. And we found c. We'll move on to the next one. It's going to be reasonably similar. We're told the slope. The slope is 0.5. We're already told it here. You don't need to calculate it. So if the equation of the line is y equals mx plus c, well here our slope is 0.5. So we're going to have y equals 0.5 x plus c. Alright, so we don't need to calculate this for this time. Our next step substitute in the coordinate. We're only given one, so we don't even have to make a choice here. We're going to substitute in the coordinate because it lies on the line. The line passes through this point. So we're going to put